Yeah, if we wanted to like again, we'd have to.
You guys
Yeah,
want
we're
to
good.
We'll yell.
We'll yell, scream at the audience.
I have an extra mic if you need one.
I think
They're sitting there, we're good.
Yeah, we should be okay.
You can hear us, right?
Yeah.
Good?
All right,
Okay.
great. All right, well, hello everybody. My name is Grant Wilk,
Austin Brenner.
Seth Koiker, Tyler Christensen,
Colt Brevard.
Michael Primeau.
and we are MSOE Senior Design Team, OXOC. We've been given the tremendous opportunity to partner with Silicon Valley tech company and auditorium namesake, NVIDIA, for our senior design project. For those of you who aren't familiar, NVIDIA is the inventor and lead innovator of a massively parallelized compute device called the GPU. Specifically, our team has partnered with NVIDIA's GPU firmware team, the team responsible for developing and managing the VBIOS, which is a collection of low-level software and data structures that allow the GPU to initialize. Ever since their inception 20 years ago, the GPU firmware team has been renowned for their reliable work in software. So much so that employees from around the company have even coined the term, VBIOS is perfect, to remark at the flawlessness of the GPU firmware team's primary product. Despite this amazing work, the GPU firmware team isn't without problems. They've never had a comprehensive firmware debugging solution that allows them to debug all the different types of firmware that they work with on a day-to-day basis. This includes UEFI firmware and GPU microcode. Our team strives to change this. We want to deliver a comprehensive GPU firmware debugging solution to the team. That way, they can debug all their firmware without having to think twice about it. Then, to test our solution and to test the efficacy of our solution, we want to leverage our previous work to implement something more tangible, that is early boot graphics, which we'll touch on a little bit later. This is a feature that has been highly requested by NVIDIA customers, and our solution proves the perfect storm to finally bring it into reality. Throughout this presentation, we'll explore each of these problems in detail and tell you a little bit about the advancements that we've made towards solving them. So with that, I'll hand things off to Tyler to talk a little bit about UEFI firmware.
Yeah, so the first problem that we are trying to solve is UEFI firmware. This is something that the NVIDIA GFW team is developing on their GPUs. And I guess the first question is, what is UEFI? UEFI stands for Unified Extensible Firmware Interface. This is essentially a newer version of BIOS, if you have used that, or which I would assume you have. It's just a quicker, more reliable, and easier way to kind of develop and essentially use a BIOS-like early boot system for your computer. And the NVIDIA team develops these as the GPU comes out of reset. This is when the UEFI comes out. Sorry. This is when the UEFI initializes when the GPU comes out of reset. And it handles very important GPU initialization tasks for the GPU. And here's just a quick little graphic to kind of show the basic steps of a UA5 Boot System. This is for generally any computer and is essentially stored on the motherboard. And here on blue, you can kind of see the basic just initialization steps for your computer. This is just some quick hardware setup. But after this is when the UEFI takes over for the system boot up. In this is when the bus drivers and all your services are really initialized for your computer. This is just so all your components can start talking to one another and are able to essentially just work together. After this is when the UEFI interface kind of is able to be displayed. This is that system where if you manage the delete key on your computer as you're trying to boot up, it'll display various components. You'll be able to modify your boot order, your just see general like CPU, GPU, or hard drive components. And then after this is when your operating system will finally take over. And this is when you'll finally just be able to use Windows or Linux or even Mac as per usual. And because of this is all before the operating system takes over, like I just mentioned. And this is really where the problem lies. We are kind of they're developing an area that is all before when the operating system has your like full suite of tools and your reliability and your usability of just being able to see a lot of different things. For example, most of you are probably fairly familiar with being able to step through coding and being able to just step through any program that you're developing. For instance, this little graphic just kind of shows you, I think this is just a JavaScript, being able to step through line by line and just being able to see different values for those variables. And this is really where the GFW team is lacking. They do not have this ability to be able to step through with like an IDE or really just anything to see their variables. They are only able to run their EFI driver that they're developing and see if it passes or fails, essentially. And because of this, they're missing out on key components like I just mentioned, such as line-by-line step-through debugging, seeing the stored values, seeing your call stack, or even being able to set breakpoints. And this is really something we're trying to set.
So for the issue of UEFI firmware debug, we really have two proposed solutions. Option one would be to develop a UEFI executable. And so what this would be is it would be an executable that we would launch from a UEFI shell. And what it would be responsible for doing is loading and executing NVIDIA's UEFI driver. And then what we would do as a team is we would add in step-through functionality and the ability to view the system state while this driver is being executed. So this would provide the engineers at NVIDIA with a way to kind of monitor the execution of their driver on the system. Our second option would be to implement a third-party debug suite. So currently there are companies out there that already implement some form of UEFI firmware debugging. And how these usually work is there is a target and a host system. The target system in our case would be the system that has one of NVIDIA's GPUs in it. And then we would also have a host system that runs the debugging software that would allow us to send step-through commands and set breakpoints and things like that. So some third-party solutions that already exist come from companies like Intel, Inside H2O, and AMI, which basically function with a USB to USB connection between the host and target system. Then there's also a company like Lauterbach, which they also have their own solution, but it's a bit more complicated in the sense that in between the two systems, they have a trace module, which handles recording the execution on the target system and sending it back to the host. So how this will help the GFW team, it will hopefully accelerate their debugging process and improve its reliability. In theory, they would be able to handle debugging in fewer iterative steps. Hopefully, they would be able to run through the code once, find any bugs that exist, and fix them without having to take multiple steps in the debugging process. Then also, through this debugging solution, it would provide them with a more in-depth system overview of what's going on in the system while the driver executes, allowing them to view the results after a single instruction is executed, and also allow them to view the system state and view any variables and things like that while the driver is executing. And I'm going to hand things off to Seth for our second objective.
Yeah, and our second objective is very similar to the first. So some of this will be a repeat, and I won't bore you with all the details, but we're taking a step now on the other side of the PCI unit. So the UEFI code is running CPU communicating with the GPU. This microcode is what NVIDIA calls the firmware that runs on the microprocessors of the device, so of the GPU. We're looking at microcode processors down below. There's about 10 to 12, depending on the device, or various numbers. And they control various things like fans, displays, or what have you on the device, as well as controlling memory management and that kind of thing. So it's executing this firmware, and currently they can debug this firmware after the device is booted. But as it is executing immediately out of reset and trying to initialize the fans, get the display, and get the PCIe lane to communicate with the UEFI shell and that kind of thing, there's no way to debug it very easily on boot. So we're looking at that primarily here. We're trying to create a solution that is very similar to that UEFI solution. We're looking at some way to implement any part of line-by-line step-through debugging, stored variable values, looking at the function call stack, your stack trace if an error occurs, or breakpoints. Ideally, we'll have all of them, but it is very challenging to implement all of them at this time. So, and when we look at it a little bit more, the solution might be to use the same software suite that we're using for the UEFI debugging, or create our own suite here. And we have to achieve this with some way of a physical connection to the GPU. So before it is able to communicate with the CPU or that kind of thing, or maybe it is. We don't have access to schematics at the moment, but we know that these processors have a JTAG interface. It's a industry standard debugging interface, so some way to communicate with them and debug the input commands, look at the current state of the processors and that kind of thing. But it's not exposed, so we're looking at some way to expose that and connect to it and create a debugging solution.
And really, the point of this solution is the same as the previous. It's looking at accelerating debug tasks. We're trying to have fewer hiccups during that development process and allow NVIDIA engineers and the GFW team to continue to make vBIOS perfect. And one very interesting thing that also we'll be able to do with this, if we're able to communicate a device before the motherboard has fully booted that UEFI shell to the screen, is maybe display something to the screen and be able to debug this through a display or some other way, or going into our third objective, use that display somehow for anything else. So Austin will explain that a little bit more here with objective number 3.
Thanks, Sam. So our third and final objective is to achieve early boot graphics using the GPU. So I'll first start by explaining what we mean by early boot graphics. So the most simplest definition of early boot graphics is graphics displayed early in the boots process of a computer system. Now, as most of you probably know, when you boot up your systems at home, what usually happens before the operating system login screen displays is both the UEFI splash screen and the OS boot screen displays first. So our definition of early boot graphics are going to be graphics that are displayed even before these. This means that these graphics must display almost immediately after reset, and that they cannot rely on the operating system, system memory, system storage, or other devices. And this is because these graphics will need to be displayed before these systems are initialized. So now, I will now talk about a problem that NVIDIA and their partners currently face that prompted us to explore this objective. So a common problem that is encountered when developing firmware or performing a post, which is a power on self-test, is that during execution, the system will give no visual indication of the status of the execution. You can usually tell if a firmware or power on self-test executes successfully, or at the very least do not fail during boot, by a full boot of the system, that being when the operating system shows up on the display. But you currently cannot receive the status of the execution in any way from the system that you are booting on. This is because the main display is not available at this time. In addition, if a fatal error occurs, such as reaching deadlock, there is no indication of where in the firmware this error occurred, making debugging and development frustrating. Now, our previous objective solutions, that being the UA5 Firmware Debug and Microcode Debug, do help with this particular problem. However, given that being able to display custom graphics during the early boot stage has also been a very highly requested feature by NVIDIA consumers and partners, we've decided that it would be great to tackle this particular problem. So I will now pass things off to Colton to talk about how we will go about our solution.
Awesome. So you guys have heard already, our problem is to try and produce a splash screen before the operating system boots up. To do this, it is the perfect bookend to our previous two objectives. We have to look through UEFI code to find the screen initialization code and move that into microcode. So having a UEFI debugger and a microcode debugger will be extremely beneficial for this. We have 3 main objectives or main ways we could do this, and that is to work around the biggest pitfall, and that is the size of the EEPROM that holds the microcode. It's only about 2 megabytes large, and that's before NVIDIA has already put its code on there. So we probably have less than a megabyte to work with. So going down from the list on the left, we have what we want to prioritize, what we think would be the best looking and the most professional. The first one is is using a compressed image. This would allow us to put any professional image we wanted in a multitude of colors, but once again, if you have an image, it's very memory intensive, and we don't want that. So the next option we have is vector graphics. If you think of the NVIDIA logo or the MSOE logo, we only use 1 or 2 colors, so using vector images really isn't that big of an issue. The problem comes is we have to develop a stronger graphics driver for that, so we have to create the vector images ourselves. And the last one, and probably the most fun, but least professional looking, is ASCII block characters. And that is basically using ASCII characters to create a logo. So say the NVIDIA logo is made by hundreds of little A's, or any ASCII character that you can think of. This would make it look like it was coming straight out of the 90s. So that's not the preferred way, but it'd be pretty cool if that's the only option we had. And then going further, we're going to see why this is even important for NVIDIA. So, like we said before, this creates an amazing branding opportunity for NVIDIA. As soon as you hit your power button on your computer, the speed of light, as NVIDIA would say, would be NVIDIA's logo pops up then your motherboards, and then the operating system. So we want NVIDIA to be the first image to pop up on the screen. Next, it creates an amazing, it creates a more organized way of unified display initialization. So you don't have your streaming initialized for microcode, then UEFI. You have it all put in one spot, right at the microcode. And I'll pass it back off to Grant for a few closing words.
Thanks, Colton. So as you guys can tell, we have a lot on our plate. Not only are we working on 2 unique firmware debugging solutions, but we're also attempting a feature that, as far as we're aware, has never been attempted in the industry before, which is kind of cool. But we're up for the challenge, and by the end of the year, hopefully the GPU firmware team will have an extensive set of firmware debugging tools. The next generation of NVIDIA GPUs will have an awesome splash screen that pops up when you boot up. And if our solution works as planned, VBIOS will stay perfect for years to come. Thank you, and with that, we'd love to answer any questions that you guys might have for us. Yes, sir.
So do you guys have any plans of how you're going to wrestle away control of the display away from the motherboard as the graphics card itself first? Are you planning on just being that much faster than the motherboard booting its own stuff up? Or do you have any idea how you're going to do that yet? Or
So the GPU kind of by nature has control of the display if the display is plugged into the GPU. So typically that's something that's handled in our UEFI driver is the instantiation of a pipeline for graphics flow from the CPU out to the display. So really from the start we have the display, so we don't really have to wrestle it. The thing is trying to get that display up and running and then also being able to write to it before we need to display anything else because a motherboard post is fairly important as well.
So I can add on to that too. So how it currently works is there's the microcode that's on the GPU itself does the basic hardware initializations and initializes like the interfaces with like DisplayPort, HDMI, those kinds of things. And then what happens is that BIOS is run very, very early. So like almost along the same lines as the system BIOS. And then the UEFI drivers are loaded after that, and the UEFI drivers can then have the full functionality for using the display after it's initialized in the GPU. So what our goal is with the early boot graphics is to move that code into the microcode, or at the very least, if we can't move everything we need, enough to get the basic display up. So that way we can have it display stuff before even the motherboard UEFI comes up.
Yeah, so at the same time when they aren't communicating to each other, we're just throwing something up on the screen to you look at, and then the motherboard is fully booted up. So it might be only a couple frames, but you'll see just like a white screen flashing NVIDIA, and that's enough for branding purposes.
Yeah.
Or you can slow it down for debugging if we're trying to get a console output or that kind of thing.
Depends on the speed of the system too. Some systems will take a lot longer than others.
Yeah.
In the back there?
Considering the early boot graphics is a completely new thing, if you guys figure it out, is the intent to keep it a NVIDIA trade secret or to have that available for all developers?
Yeah, the idea of implementing it will be very proprietary to the firmware that NVIDIA is running. So we'll have access to their firmware and won't be able to provide that to someone else. But if we ended up getting a job at AMD or something and they want to do something similar, they hadn't figured it out, yeah, we could implement it, but it's really not something that will be quite a trade secret in that way.
Unique to their products for
Yeah.
now is what the plan is.
Yeah, and the plan is not to have just people be able to upload their own custom graphics, as cool as that would be. It would kind of let in some security issues that we need to be aware of.
And it's worth noting too that we're basically just writing out via an existing frame buffer to a display via a standardized display protocol. So we're just writing out an image through DisplayPort, which really isn't proprietary in nature and anybody can do per the standard. But yeah, the integration with NVIDIA's microcode will be proprietary. Yeah. Oh, sorry. Yeah, sure.
Is the intent to show exclusively the NVIDIA logo, or like, for example, if you have NVIDIA board partners, where it's NVIDIA chipset on, like, for example, like another manufacturer's board, would the other manufacturers be able to use your standard to write whatever their logo onto it?
Yeah, that's something that definitely could be done.
It is ultimately up to NVIDIA,
Yeah.
but it is a feature requested by their partners. So I imagine for at least the OEMs like MSI and Asus, they'd probably be able to throw up their own graphic. I don't know if it'd be fully available to everybody though who uses the card.
Yeah.
Yeah.
Very cool.
Thank you. I have feedback forms, if anyone needs one still.
Where you came from?